This is the MV Agusta F4 CC. It costs $120,000. Only 100 were ever made, and the engine inside it started life as half a Ferrari Formula One V8, not inspired by Formula One, not loosely based on Formula One. The engineers who built the prototype were Ferrari engineers. The architecture they started with was Ferrari Formula One architecture. And when you open the throttle on one of these 100 motorcycles, a version of what Ferrari put in their 1990 F1 car is what sends you down the road. 100 units, $120,000 each, and every buyer received a Swiss luxury watch in the crate alongside the motorcycle, numbered to match their bike's serial number. The man whose initials are on the tank also saved two of Italy's most famous motorcycle brands from oblivion. He bought a dormant factory trademark for virtually nothing. He hired the designer critics called the Michelangelo of motorcycle design. He got Ferrari to help build the engine, and then he put his own initials on the result. His name was Claudio Castiglioni. He died 3 years after this motorcycle was released. And the F4 CC is what happens when someone refuses to build a compromise. Claudio Castiglioni is the reason MV Agusta exists at all. The original company, the one that won 75 World Championships and 270 Grand Prix races through the 1950s, 60s and 70s, went out of business in 1980 when the Italian government withdrew its financial support. The brand sat dormant for 12 years. Nobody bought it. Nobody revived it. It just stopped. In those 12 years, MV Agusta's reputation didn't fade. The bikes they had built in the 1950s and 60s, the 500 cubic centimeter Grand Prix machines, ridden by Giacomo Agostini, the most successful motorcycle racer in the sport's history at that point, were already becoming collector pieces. The name carried weight it had no current production to justify. A brand with 75 world championships to its name, sitting silent in a closed factory, is the kind of situation that most people look at and walk away from. Too much history, too much expectation, too difficult to live up to. Castiglioni, who was running an Italian motorcycle group called Cagiva, bought the MV Agusta trademark in 1992. Not the factory, not the tooling, not the team, just the name and the right to use it. He had already saved Ducati once, purchasing the brand in 1983 when it was close to collapse and restoring it to profitability before eventually selling it to the Texas Pacific Group in 1996. Buying dormant Italian motorcycle brands and making them extraordinary again was, it turned out, something Castiglioni was unusually good at. He paid what the name was worth to a company that no longer made anything, which was very little. Then he commissioned Massimo Tamburini to design a motorcycle from scratch. Tamburini was the man who'd already designed the Ducati 916, widely considered the most beautiful production motorcycle ever made. He was based at Cagiva's research center in San Marino. Castiglioni gave him a blank sheet of paper and told him to build the most extraordinary Italian motorcycle that could be built. The result was the F4. It was shown publicly in 1997. Within a year, the original version, the F4 750 Serie Oro, had been exhibited at the Guggenheim Museum in New York as part of the Art of the Motorcycle exhibition. Not as a tribute to the brand's history. As a contemporary object, considered significant enough to sit alongside the greatest motorcycles ever made. The man critics called the Michelangelo of motorcycle design had done it again. The F4 CC came 9 years later. By 2006, the F4 had grown into a 1,000 cubic centimeter platform, developed through multiple iterations, and Castiglioni decided to mark the occasion in the only way consistent with the project's origins. He put his own initials on it. CC, Claudio Castiglioni. He said publicly, "I decided to put my name to this bike as I originally dreamed of it for myself. 100 units, that was all. The most extreme expression of a motorcycle that began in a Guggenheim exhibition, and it was going to be built exactly 100 times. The numbers on the F4 CC tell a very specific story. Let me walk through them. Length is 2060 millimeters, just over 81 inches. Wheelbase is 1410 millimeters. Seat height sits at 810 millimeters, just under 32 inches. It looks exactly like what it is. A compact, tightly packaged Italian superbike with nowhere a gram of unnecessary material could hide. Dry weight is 177 kilograms, 390 pounds. For comparison, a contemporary Yamaha YZF-R1, one of its closest competitors in the litre-class superbike segment, weighed around 172 kilograms in the same era. The MV Agusta makes significantly more power from a larger displacement engine and comes in within 5 kilograms of a bike known for being extremely light for its class. That's what happens when you use titanium for components most manufacturers make from steel. Power output is 200 horsepower at 12,200 revolutions per minute at the crank, 163.7 horsepower at the rear wheel, the figure that actually reaches the tarmac after drivetrain losses. Torque is 92 pound-feet, 125 Newton-meters, at 9,000 revolutions per minute. Top speed, 195 miles per hour, 313 kilometers per hour. That top speed figure is the one that most people focus on. But there's a number inside this engine that matters considerably more than top speed. And to understand it, you need to understand what Ferrari actually contributed to this motorcycle. The engine inside the F4 CC is a 1,078 cubic centimeter inline-4, liquid-cooled, double overhead cams, 16 valves, 4 cylinders in a row. Standard architecture, on paper. Every performance motorcycle in this class uses something similar. What makes this engine completely unique is where those 16 valves sit. On a conventional 4-valve per cylinder engine, which covers essentially every high-performance motorcycle engine produced in the last 40 years, the valves are arranged symmetrically around the combustion chamber. 2 inlet valves on one side of the chamber, 2 exhaust valves on the other. The valve stems point upward into the cylinder head in a more or less parallel arrangement. Standard, effective, universal. On the F4 CC engine, the valves are radial. They point outward from the center of the combustion chamber like the spokes of a wheel, each valve angled away from the center axis rather than running parallel to it. This is not a small difference. It changes the geometry of the combustion chamber fundamentally. With radial valves, each valve head sits closer to the cylinder wall and further from its neighbor, which allows the chamber to be more hemispherical in shape. A hemispherical combustion chamber is the ideal shape for internal combustion. It gives the largest possible volume for the smallest possible surface area, which means less heat loss through the chamber walls, more complete combustion, and higher thermal efficiency. Ferrari had been using radial valve technology in Formula One engines since the late 1980s. It was part of why their engines made the power they did. When Ferrari engineers sat down with MV Agusta, then Cagiva, to develop the F4's prototype engine, they brought this technology with them. The initial engine design was literally structured as one bank of a Ferrari F1 V8, 4 cylinders, radial valves, Ferrari engineering methodology. MV Agusta and Cagiva eventually departed significantly from the original Ferrari design as development progressed. The displacement, the bore and stroke, the fuel delivery, the cooling system, the output characteristics, all of it evolved away from the Ferrari prototype over years of development. But they kept the radial valves, and to this day, the F4 engine remains the only recently produced radial valve multi-cylinder motorcycle engine in existence. Every other manufacturer looked at radial valve technology and decided the engineering complexity wasn't worth it. MV Agusta decided it was, and kept using it for 19 years across every variant of the F4, right up until the last model rolled off the line in 2018. The F4 CC takes that radial valve engine and pushes it further than any other road-registered variant. The bore was increased by 3 millimeters over the 998 cubic centimeters F4 1000R, giving the additional displacement. The intake valves are larger in diameter. The valve train is manufactured by Del West, an American specialist who supplies components to Formula One teams. Titanium valves, titanium connecting rods, titanium crankshaft. The crankshaft is both balanced and lightened by MV's own racing department, the same people who campaign their bikes in World Superbike competition. The end result is an engine that weighs 8.8 pounds less than the already lightweight F4R unit, while producing 26 more horsepower. Then there's the TSS system, torque shift system, 4 variable length intake ducts that change their effective length depending on engine speed, controlled by the engine management unit. At lower revs, the longer duct configuration favors torque. It shifts the torque peak from 10,000 revolutions per minute down to 9,000, making the power more usable in real road conditions. At higher revs, the system switches to shorter ducts and releases the full top-end power. The same engine, at the same throttle position, is operating differently above and below 10,000 revolutions per minute. Most engines have to choose between mid-range character and top-end power. The TSS system refuses the compromise. This matters more than it sounds. On a racetrack, an engine that only makes power at the top of its rev range is manageable. You keep it there. On a public road, that approach is impractical and frankly dangerous. The TSS is what allows the F4 CC to be genuinely rideable at normal road speeds while still producing 200 horsepower when you need it. Without it, the engine's top-end bias would make low-speed traffic either tedious or terrifying. With it, the engine delivers usable torque from the moment you open the throttle in any gear. MV Agusta was the first manufacturer to use this system on a production motorcycle. Nobody else has copied it. That's a remarkable statement about an industry where competitive imitation is the primary engine of development. The fuel injection system is electronic multi-point, 1 injector per cylinder, managed by a Weber Marelli ECU. The same ECU supplier used in Formula One. The engine management calibration was developed by MV Agusta's racing department, not their road bike engineering team. The road bike and the race bike share their ECU supplier. They also share their approach to calibration, extract maximum power within the constraints of reliability. On a road bike, those constraints are different from a race bike. Longevity matters in a way it doesn't over a single race distance. But the methodology is identical. The exhaust is a full titanium system, not titanium coated, not titanium heat shielded, but titanium from header to tailpipe. It exits beneath the seat in MV Agusta's signature 4-pipe configuration, which has been a visual trademark of the F4 family since the original Serie Oro in 1999. At full throttle, the sound it produces is one of the most discussed aspects of any motorcycle reviewed in that decade. Motorcyclist magazine described it as sounding like an F1 car at full chat. That comparison, given the engine's actual origins, is not entirely a coincidence. If you found this level of detail useful, and we go this deep on every video, hit subscribe. There are more coming in this series, and each subject is stranger than the one before. The button costs nothing. It means we can keep doing this. The chassis around that engine is a hybrid structure that MV Agusta pioneered and used throughout the F4's production life. A chrome moly tubular steel trellis forms the main structural skeleton, high tensile, lightweight, with the visual complexity that Italian designers traditionally embrace. 2 cast aluminium alloy plates bridge the trellis at key structural points. The engine itself is a stressed member of the chassis, carrying load between the front and rear suspension pickup points. Removing the engine doesn't just leave a hole in the powertrain, it removes part of the structure. The single-sided swing arm is an MV Agusta signature. It's both functionally purposeful, allowing wheel removal without disturbing the brake system, and visually striking. On the F4 CC, it's finished to a level of detail consistent with everything else on the bike. Machined, not cast, with surfaces that show the quality of the manufacturing rather than hiding it. Suspension is a 50mm inverted telescopic fork at the front with 130mm of travel and an F1-derived monoshock at the rear with 120mm of travel. The rear shock was developed with reference to Formula One damping technology, another thread of the Ferrari connection running through the bike's engineering. Both ends are adjustable, and on a motorcycle this light and this powerful, the adjustability matters. Different riders at different weights and riding in different conditions will set this bike up differently. The range of adjustment is wide enough to accommodate that variation without compromise. Brakes are dual 310mm discs at the front, gripped by Brembo 4-piston calipers, a single 210mm disc at the rear. The Brembo specification here is not the standard production item. These are units from Brembo's higher performance range, developed for competition use and filtered down to road applications. The braking feel under hard application has been described by every journalist who tested the bike as immediate and progressive, exactly what the power output demands. The bodywork is full carbon fiber. Every fairing panel, every shroud, the front mudguard, the seat cowl, the airbox covers, all carbon. At the power-to-weight ratio this bike operates at, every gram removed from non-structural surfaces is a gram that goes into performance rather than cosmetics. It also looks extraordinary. The combination of Italian styling, Tamburini's original lines, developed and refined over 9 years, with carbon fiber surfaces, creates an object that justifies the Guggenheim comparison more than most people expect. The 10-spoke alloy wheels are another detail worth noting. MV Agusta specified these across the F4 CC specifically, 10 spokes arranged in pairs, the gap between each pair deliberate and designed to complement the visual language of the rest of the machine. Whether you notice the wheel design on first viewing or not, it registers unconsciously. Every visual element on this motorcycle was considered at that level. When you bought an F4 CC, MV Agusta didn't just ship you a motorcycle. The delivery included a numbered Girard-Perregaux watch, a Swiss luxury timepiece numbered to match your bike's serial number from the 100 produced, and a Trussardi leather jacket, custom to the purchase. 3 objects, all numbered, all connected. The motorcycle, the watch, and the jacket form a set. Separate them, and each becomes less than the sum of the 3 together. This packaging decision tells you something about how MV Agusta understood the F4 CC's buyer. This wasn't a motorcycle purchase for someone who needed transportation. It was an acquisition, an act of collecting, of ownership in a broader sense than riding something to work. The watch confirms it. The jacket confirms it. You weren't buying performance. You were buying into a statement about what $100,000 spent on a motorcycle could mean. Claudio Castiglioni died on August 17, 2011. He was 64 years old. He'd been ill for some time. His son Giovanni took over the company. The F4 line continued in production until 2018, when emissions regulations made the engine's architecture impossible to certify without fundamental redesign. Rather than change the engine, MV Agusta ended the F4 entirely. The last special edition, released at ICMA in November 2018, the same show where the original F4 CC had been unveiled 12 years earlier, was named the F4 Claudio. 100 units, his initials in the name, 100 units at the beginning, 100 units at the end. The man who paid €1 for a dormant motorcycle brand commissioned the Michelangelo of motorcycle design to build something extraordinary and put a Ferrari-derived engine at its heart. His name bookended the entire production history of the motorcycle he'd created. Between the F4 CC in 2006 and the F4 Claudio in 2018, MV Agusta also sold a majority stake to Harley-Davidson in 2008 for $109 million. Harley sold it back 2 years later, deciding that the Italian superbike market wasn't what they wanted to be in. Castiglioni reacquired the company he'd built for €1. €1. The man had a habit of buying Italian motorcycle brands for approximately nothing and turning them into something that mattered. He did it with Ducati. He did it with MV Agusta. He did it twice with MV Agusta. When he died in 2011, the brand he'd revived from silence was producing some of the most desirable motorcycles on Earth. The F4 CC, with his initials on its fairing, is the single clearest expression of what that project actually meant to him. So, verdict. What the F4 CC genuinely delivers: a 100-year-old racing heritage in a motorcycle that still, in 2024, produces an engine architecture that no other manufacturer has copied. The Radial-Valve technology isn't a historical curiosity. It's a superior engineering solution that MV Agusta implemented and everyone else chose to ignore because it was harder to do. The power output is real. The weight is real. The titanium is real. Not a trim item, but structural and rotating components, where titanium's strength-to-weight ratio is the only reason the performance numbers work. And the Tamburini design is genuinely extraordinary. These motorcycles appear at auction now with under 2,000 kilometers on them. People buy them and don't ride them because the appreciation in value makes riding them feel expensive in a different way. The complications: the F4 CC is now 17 years old. Modern electronics, traction control systems, cornering ABS, quick shifter, riding mode selection, don't exist on this bike. A 2024 Ducati Panigale V4 offers all of these systems as standard. A buyer who spends $120,000 on an F4 CC today is getting a motorcycle that is electronically less sophisticated than a $30,000 production superbike from any current Japanese manufacturer. The 2024 superbike market has moved so far forward that 200 horsepower is no longer a claim that stops a room. And the Radial-Valve engine, for all its technical purity, requires a level of mechanical sympathy that buyers of contemporary superbikes rarely need to develop. This is not a motorcycle that tolerates casual ownership, but there's a version of the verdict that matters more than either of those points. 100 motorcycles exist with Claudio Castiglioni's initials on them, built around a technology he helped bring from Formula One to the street in a company he bought for next to nothing because he believed it deserved to exist again. The motorcycle world is better for that belief. Whatever the bike costs now, and values have risen considerably, the original 100 buyers paid for engineering that was genuinely worth the price. The watch and jacket were just confirmation. In the last episode, we went inside a motorcycle that a department store sold through a Christmas catalogue for $110,000. All 45 sold in a single day, and one of them later sold at auction for $11 million. If you haven't seen that episode, it's in the description. Next time, we're looking at a motorcycle that a Japanese manufacturer built to be street legal, then told buyers they probably shouldn't ride it on the street. It's their factory MotoGP machine, road registered, $184,000, 250 units. And there's a package you can buy alongside it that makes it genuinely faster than a motorcycle you can legally race in the most competitive production-based championship in the world. We'll find out what's in that package and whether the engineering justification for the price tag survives contact with a stopwatch. Some of the financial and production history of this bike is more consistent in some sources than others. If you find a factual discrepancy, please let us know in the comments. We take those corrections seriously. Thanks for watching.